This video is going to take you through the process of transcription. Transcription is the process of taking DNA and creating an RNA molecule off of the DNA, specifically mRNA in this case. So the DNA is going to act as the template, and the mRNA will be formed complementary to that template. The enzyme that helps catalyze this process is RNA polymerase. RNA polymerase is the red enzyme seen in the picture. It is similar to DNA polymerase, however, also performs the function that helicase does during DNA replication. RNA nucleotides are very similar to DNA nucleotides. They have a 5' end and a 3' end, and they are made out of a phosphate, a sugar, and a nitrogenous base. The difference is that the sugar in this case is ribose, and the nitrogenous base thymine is replaced with a different nitrogenous base, uracil. Transcription starts when a DNA molecule enters the enzyme RNA polymerase. So the DNA enters and it is first unwound. When the template strand of DNA, the one that will match up with the RNA, reaches the active site, an RNA nucleotide that is complementary to that DNA nucleotide enters the active site as well. It is attached to the DNA and the DNA moves forward. Then the next mRNA nucleotide is also attached. Once that happens, the last RNA nucleotide separates from the DNA. This is a crucial function of RNA polymerase as it allows the RNA molecule to be its own molecule and leave the nucleus to head to the site of translation, the next step in protein synthesis. Note that as transcription continues, the mRNA molecule builds and the DNA molecule exits the RNA polymerase on the other side, coming back together. If we speed things up, you can see how the mRNA molecule is synthesized over time and the DNA comes back together, leaving the DNA intact for future transcriptions. The end result is a single-stranded RNA molecule that will go on to leave the nucleus and go to the site of translation, the next step in protein synthesis.